Hi, kiddos! Time to talk about combined gas law, hashtag CGL. Yes, hashtags are not going away anytime soon. So the combined gas law is where we take all of those gas laws we learned, Boyle's, Charles, and pre-AP learned Gay-Lussac's as well, and we actually put them together in one combined equation.
Yep,
Right, so
because they're all related, pressure, volume, and temperature.
Pressure and volume divided by temperature is equal to pressure and volume, again, the second measurements divided by temperature. This is combining everything together. Now, here's the deal. Let's say, just for argument's sake, if temperature was held constant and we took temperature out, what does that look like to you?
That looks like Boyle's law.
It looks a lot like Boyle's law. All right. So if we take that out, let's say we held pressure constant and we took out pressure and ignored it completely. We have V over T equals V over T. What does that look like to you?
Charles' law.
Charles' law. Starting to sense the pattern here. And then the other one, the last one, that for pre-AP, if you take volume out and you have pressure over temperature.
That's Gay-Lussac's.
Gay-Lussac's law. So you guys can see how it's just, if one of those is held constant, then you can ignore it completely. But in the combined gas law, we're looking at if all of them are changing.
Okay.
So let's do a couple of example problems. What do you say?
Okay, so let's say we have a gas that has a volume of 1.5 liters at 1 atmosphere.
So P1 is 1 atmosphere, and the volume was what?
1.5 liters.
1.5 liters.
And we're at 25 degrees Celsius, so we're at room temperature.
25 degrees Celsius. Okay.
And then we're going to decrease our pressure to 0.8 atmospheres.
Pressure 2 would be 0.8 atmospheres.
And we're going to decrease our temperature to 20 degrees, or negative 20 degrees Celsius.
Okay, negative 20 degrees Celsius.
And we want to know the new volume.
Okay, so we're trying to find that new volume. We need to set all this up, put all of our numbers in here, but first we have to convert our temperatures to Kelvin.
Right, always, always Kelvin.
So 25 degrees Celsius plus 273 gives me what?
298.
298 Kelvin. We're just added 273 here. And negative 20 plus 273 would then give me?
253.
253 Kelvin. Okay, now we're ready to plug these numbers in.
Okay.
So let's do it. So let me just give a little separation here. So P1 is 1 atmosphere times V1, which is 1.5, divided by 298 equals pressure 2, which is 0.8, times volume 2, almost ran out of room there, over 253.
And a way to make your lives easy is to make a list just like Mr. Veve did, where you do P1, V1, T1, and P2, V2, T2, and identify what you have, what you're given first.
I always like to organize things. That's kind of best way to make sure you don't make mistakes. So now what we got to do is we have to cross multiply. Since we have denominators here, I don't like those. Let's get rid of those. So what we got to do is we need to cross multiply this stuff, and this is on one side of the equal sign, and then the other stuff is on the other side.
Right.
So let's see what that looks like. So we've got 1 times 1.5
times 253
times 253 equals the other stuff. We've got 0.8, we've got 298, and we've got our unknown, which is V2. So what we have to do, remember, we have to divide both sides by this right here to get V2 by itself. It takes a long time to write out math problems. I'll tell you what. Okay, these will cancel out. V2 is going to be equal to that stuff over on the left-hand side. If we work it all out correctly on our calculator.
Our new volume is 1.59 liters.
1.59. And how did you know it was liters?
Because I started with liters, so we had to end with liters.
All right, and that's a very good point. Make sure that you always have the same units for each of your pressure, volume, and temperature. So remember, we had to convert our temperatures to Kelvin, but let's say one of our atmospheres was in millimeters of mercury and one was in atmospheres.
You have to convert one of them.
You could just pick which one you want to convert for combined gas law only. So just always make sure of that. That's pretty clear for that one. You want to do one more?
Sure. Let's do another one.
All right.
Now let's do one with millimeters of mercury.
All right. So I'm going to make my list P1, V1, T1, P2. Oh, that's a little too close. P2, V2, and T2. All right, so
Okay, so let's say we start with 5 liters at 300 Kelvin.
5 liters at 300 Kelvin.
And the pressure is 1,000 millimeters of mercury.
That's a high pressure situation. Kind of like your benchmark. All right, what else?
Okay, and then the new volume is 2.5.
New volume is 2.5.
So we're going to cut the volume in half and increase the temperature to 350 Kelvin.
350 Kelvin.
That's pretty hot.
So you see how like she was just reading me off the problem and everything, and I was just plugging in where I could. I didn't ask for a specific order, just went as we go. So what is that new pressure going to be?
Well, let's plug everything in.
Plug everything in. So P1 is 1,000 times V1, which is 5, over T1, which is 300, equals P2, which, I don't know, we don't know what that is, times V2, which is 2.5, over T2,
350.
which is 350. Again, we are going to cross multiply. This stuff all multiplied together will be on one side, and then the other stuff will be on the other side. So we are going to have 1,000 times 5
times 350
times 350. This is going to be a big number. Equals P2 times 2.5 times 300. We're going to divide both sides by 2.5 times 300 to get rid of this. Because remember, then what we have to do to one side, we got to do to the other side. Now, if this is not the way you like to do your math problems, this is just one way. As long as you get the same answer that we do, it doesn't really matter.
Yep, you can treat each side independently if that's easy.
So in this case, our P2 is going to be equal to what?
2,333 millimeters of mercury.
Millimeters of mercury. That's.
And what if we had asked for the answer in atmospheres?
Well, if we had asked for the answer in atmospheres, you solve for it in millimeters of mercury, and then all you have to do is convert millimeters of mercury to atmospheres.
So divided by 760.
So you divide it by 760.
It's 3.07 atmospheres to give you a reference to how high that pressure is.
3.07 atmospheres, 3 times the normal pressure. If you guys want to practice, see if you can convert that to atmospheres. If you get it right, great. If not, go back and watch the conversion video, see if you can get a little more help. I hope you enjoyed combined gas laws. I know we enjoyed making this video.